Go, three.
Wait.
Up. All right, ladies and gentlemen. So today we're talking about measures of central tendency, which probably sounds a little bit weird. But what I'm referring to is in a set of data, I have a few ways that I can talk about a number that kind of represents the middle area of that data. All right? Like if I asked you what's the center of this data, what's one number that represents all of it? That would be a measure of central tendency. All right, so we actually have a few different ways of measuring central tendency. The first of which is the mean. All right, sometimes referred to as the arithmetic mean. And the mean, how did you guys define that? Right, it's often thought of as the average, but how would you describe what actions you would take if you were trying to find the mean?
What's the mean?
Right, add them all together and divide by how many there are, right? Add together, divide by
We went over this yesterday.
number of them, right? Yeah, a little bit, but we're going to extend it a little bit further. Number of, I guess I'll call them elements or terms. We might call them terms, I don't remember. Values, I guess. Now, I'm going to show you a formula for this. X bar, capital X bar, is going to be a formula that... Right, X bar just means the mean, all right? And imagine if I have a list of X1, X2, X3, all the way to X sub n. So I've got n terms, all right? N many terms.
Well, that's a pretty good, yeah.
Okay? And I want a formula that's going to calculate the mean of this list, right? So those numbers could be anything, right, in any order. So what I'm going to do is add them all together. Now leave some space here.
Oh, God. You said that earlier.
So leave just a little bit of space here for a moment. And this, actually... You might have spotted this symbol in Excel the other day. I don't know. Does anyone know what that symbol is?
See those sorts? Auto sum. Sort, A to Z.
Auto sum. This symbol is the Greek letter sigma, and it's referred to, sigma is like the letter S, and it's the Greek letter sigma because it represents the sum of a list. All right, a sum of some number of elements. All right. So we're going to add the following elements. We're going to add from I equals 1 to n.
One.
Each term x sub I. And that's not I as in like the imaginary number I, but just I as in like that particular element. So if I'm referring to the, when I is 3, I'd be referring to the third term in this list. All right, when I is n, I'd be referring to the nth term of this list. And what this tells us to do is just add up every element, right? So plug in 1 for I, so take the first one. Add that to when I plug in 2 for I, add that to that one, right? Add that to when I plug in 3 for I, 4 for I, 5 for I, all the way to n. All right, so this tells me where to stop. This tells me where to start. All right. This I number, by the way, is referred to as the index of summation, but I'm not too worried about you knowing all that stuff right now. I think we end up covering it later on a little bit more in depth in my pre-calculus course anyway. So yeah, this is a 1, this is an I. Yeah. But this just means add up all of the terms. So if I said add up this squared, that would mean add up the square of all of those terms. All right, or if I said add up all of those terms times 3, all right, that's what that would be. So it'd be saying multiply each term by 3 and then add it to the other ones. right?
Oh,
So that's what that would be referring to. So this is a mathematical notation way of saying add together, all right? And now what do I want to do after I add them together? Divide by how many there are. How many terms are there? N many terms. So I could put this all over n, but the way that we'll represent this is multiplying by 1/n, right? Which multiplying by 1 over n, multiplying by a reciprocal is the same as dividing by that denominator. So this is just a little bit of a intro to this sigma notation. All right? Sigma notation. And we're going to use a little bit of that today. And it's the same sigma that you see in Excel. All right. So you guys have calculated averages before. Let me ask you kind of an interesting average question. What if, let me ask this question. Let's say these are some grades. All right. Let's say you've got 72.
47.
64.
47.
A 91.
47.
And some yet to be taken test. Okay? And let's say you want an average of, I don't know, let's say you want an average 80. Is that even going to be possible?
Yeah.
Yeah, let's say you want an average of 80. So the question is, what do you need to get on the next test in order to have an 80 average?
22 plus 64 plus 91 plus x divided by 4.
Okay, yeah, so let's, use the concept. So add them all together and divide by how many there are.
By 4.
So x plus all of those things. All over 4 should equal 80, right?
Mm-hmm.
So now how could I solve this?
Well, it's 240 x plus 72 plus 64 plus 91 equals 240.
Okay, so you're multiplying both sides by 4 to
Uh-huh.
get 240. Right?
And then use
X plus, what's that? 72 plus 64 is 6. What's that? 146
Yeah.
plus 91 would be
237. No, 37
equals
to
240.
And then you subtract it.
Okay, perfect. And I end up with x equals
3.
Wait a minute. Did we do that right?
No, I think we.
Let me just use.
Yeah, 4 times 8 is 320.
Yeah, 340.
You said it so confidently, which is half of any argument. You just have to say it confidently. So let's see, what is 320 minus that? 93?
83.
Let's see, 120. Yeah, I think it's 83, right? Right? So that's one way we can solve this. Now, an interesting thing about kind of averages, the way I think about it, is over-under kind of thing. So watch this. This is kind of like a little bit of an analytical way. So 72 is how far below 80? It's 8 below. 64 is how far below 80? 16 below. 91 is how far above 80? 11. And then, so basically, I'm looking for a number that will be whatever above 80 to counteract and balance out those. So that's kind of the way I like to think about it that way too, just in terms of some awareness there. So that's negative 24. So I would need a 13 above 80. I did add the numbers wrong. Wow, we were all over the place. Is it 227?
What's 227?
Wow, guys.
72
This is the best
plus
math
64
ever.
Plus 91 times 4 divided by 4 equals 227.
Why'd you multiply by 4? Why'd you do 91 times 4?
Oh,
Yeah. Well, anyways, yeah, the answer is 93. One way or another. At least according to this little check. Right? Yeah. Yeah. So what did we do wrong? Is this supposed to be 227? Yeah. And then 93?
Oh, look at that. My way worked anyway. So,
Right. So that's one of the ways you can kind of think about that. So this is kind of an interesting problem. I know you've calculated averages before. This is kind of using its formula backwards a little bit to find a particular number. All right. So let's see. What about median? We talked about. So how could you describe the logic of finding the median? Right? So it's the middle number when the list is in order. And then there's a but or an if. If there are two middle numbers, what do we do? Two middle numbers. Find their mean. Or just add them together, divide by 2. Right? Because it'll always just be between two numbers, right? So that would always work. Right? So to find the median of a list, right, that's not terribly difficult. I guess we'll do, no, we'll actually save it for once we do the other ones. And then mode is the most frequently occurring number. And if it's a tie, it's bimodal. If tie, two-way tie specifically, bimodal. If three-way tie or more, you would say no mode. Right? So it's no mode, for instance, if every number occurs exactly the same number of times. Like if every number occurs once, it's no mode.
no mode. No mode.
No mode. Okay.
Samuel Mode.
So let's talk about stem and leaf plots. Stem and leaf. So a stem and leaf plot is kind of a visual chart, a way to arrange data in a different order, all right, or a different way. But this is the idea. So suppose, I'm just going to do an example, I think. I'm not even going to explain it. I'm just going to do it and then show you how it works. So suppose we have a list. Let's let's see. Let's have you guys give me your favorite number that's an integer between 1 and 100. All right.
88.
So 88. There we go. Yeah. Next. Give me some more numbers.
73.
Jason.
I'm not ready.
Give me a number.
I want 3.
3.
72.
72.
3.
54. My number.
Just has to be a number.
15.
So then a number to letter to.
15.
11.
24.
24.
28.
28.
Yes.
11.
Damn it.
7.
7,
America.
74.
0.
74,
12.
and
12.
and
12.
12. Fine. All right, so here's a list of numbers, right? So what I'm going to do is put these in a stem and leaf plot. And what that looks like is this, where I
Oh, I should write those.
am going to, yeah, I'm going to have on one side of the line have some of the digit, like one of the digits represented. And I could have the digit be both the tens and the hundreds, or just the tens, right? I could have it kind of be all sorts of different things to be able to divvy it up. The right-hand side will be like my ones digit or whatever's left over. So in this case, I want to have, I've got some 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right?
8,
And my key for this, which a stem and leaf plot is useless if you don't have a key, my key will be that 7 line 2 means 72. If you don't have a key, your stem and leaf plot is not able to be interpreted. Because I also could have had this represent 7 line 2 means 720.
Or 700 and...
Or 7.2. Or 0.72.
Or
All right.
0.072.
Or 7200, right? So, so I just want to point out that that's what this is. So the line represents some break in the digits somehow, all right? So let's represent these, and when you do this, you have to represent these in order. So let's see, let's look at our any numbers less than 10. So I had 3 occur twice, right? So I'm going to write 3 and 3. Let's see, let's look at our teens. I had 11, so I'm going to put a 1 here, a 12, and a 5. I don't think you need to.
Why are you putting those numbers?
I suppose you could. No, you don't need to. So,
Oh, I got it again.
we got it?
Yep.
All right. Let's look at the 20s. So I had, 24 and 28.
Should we put them in order, right?
Yeah. Let's see. No 30s. Okay, how about 40s? None. 50s?
No.
Yeah, 54.
54?
60s, no.
69.
69. 72
74.
and 4.
88.
88.
There's no 90s.
And no 90s and no 10s. All right. So this ends up being a stem and leaf plot, and this is somewhat related to a frequency distribution. All right. If I wanted a frequency distribution that represented the same data, I could have had kind of the 0 to 10 range, the 10 to 20 range, the 20 to 30 range, right? And I would have had, for 0 to 10s, it would have been 2. For 10 to 20, it would be 3. For this one, it would be 2. For 30 to 40, it would have been 0, right? I missed 7.
Yeah. 7. You were missing one.
Oh, regular old 7. Yeah, you're right. Straight up 7. I got you. So I just want to point out that we could represent it like this. And now when data is in this order, we can also use it to calculate a median since it is sorted. But yeah, so we're going to take a quick break and be right back.
Nice.